redundant in how I record my lectures. I will record my lectures on Zoom. I will record my lectures on Zoom, but I also am using the software that comes with my camera to record lectures. Because sometimes the Zoom is not, the network, at least I have at home, breaks up. And so when you watch the video is going to be bad. But the one that I record at home will be fine. The only problem I have with the one at home is that sometimes the video gets too long because I'm doing this on a Mac. And it'll actually stop and then I can restart again. First thing I want to talk about is the lab kits. The lab kits, because of the poor air quality, the lab kits will not be passed out until next week. Okay? So no lab kits until next week. You're going to get an email from our division office regarding the lab kits sometime later on this week. Okay, which is actually good for us that we're delayed a week, because for you guys, I don't have all the equipment in yet. We've got all shipped in. Okay. So at some point, we'll get an email from them, and then you'll also get an email from me as a reminder to pick up the lab equipment. It's going to be a system where you're going to be in the DRE lots, the lot parking lots with the solar panels. You're just going to drive up, show us an ID card, show us your schedule. We'll hand you the equipment. Now remember, the equipment has to be returned. Not all of it. Some of the equipment has to be returned. So some of that stuff is expensive. Okay. We have oscilloscopes to be using for $20 each, but when we have 50 students using them, that's 50 times 20, it's $1,000. So it adds up. So we need the equipment back, and if we don't get the equipment back, we will put a hole in the grave. So we really need it. Okay, it's important that we get some of the other stuff, the consumables, you'll have balloons in there. We don't need the balloons back. Okay, but the actual instrumentation that you're going to be getting, you need it back. Like I said, you can actually buy them yourself, although it took a long time to get to your house. I bought them over the summer. It took like a month to get. But it's good. It's good equipment. Yeah. So wait for emails regarding the lab kits. I'm going to skip this until we actually talk about this in the lecture. The WebAssign. I created a copy of WebAssign from last semester, which used the same textbook you used in 205. But, and this might be my fault, something happened, and so it's asking people to pay for the WebAssign. Don't pay for anything. Okay? I've contacted WebAssign regarding the issue I'm having. I've been frustrated because they haven't responded. They used to be fast to respond, now they're not. But don't pay anything. If worse comes to worse with WebAssign, what I'm going to have to do is create a new class in WebAssign that you access with the correct textbook. Okay? So anyway, don't pay anything in WebAssign. All right? Please don't pay anything in WebAssign, because if you were in Physics 205 and you paid for multi-term with your access code, because that access code was for multi-term. Oh, okay. But did you take, Andrew, did you take 205 here? Okay. Let's see what I can do with WebAssign. They have not been responsive. What I'll do is, if worse comes to worse, I'll leave them both up. But I mean, I'm going to see if I can get your refund. You shouldn't have to pay again, because when you took 205, you didn't pay multi-term. Oh, okay, so that's different though. If you took 205 and you only paid for one term, they're going to make you pay for it again. Sorry about that. But usually that code they give you when you take 205, Okay, well, we'll see if there, we'll work on that, I guess. Okay. But usually when you get that, when you come through Sierra College at 205, Physics 205, you get a multi-term version of the web assignment. Okay. Anyway, so don't pay anything. Okay. So I had asked you all to watch the video that's on the Canvas site on the homepage. Do you have any questions regarding the lab? Oh, there you have it. Okay, yeah, I think Shakal told me that you guys set up a Discord. You know, if you feel more comfortable without me, I don't know. I mean, it's a good question regarding joining the Discord. I would like for you guys to discuss things. I mean, I would like for you guys to communicate with each other. I mean, yeah, I can. If you guys don't want me to join it, I'll join it. That's fine. Okay. Just tell me. Just send me an email with whatever I need to do, and I'll do it. So I took. So I got. This brings up a question. You brought up the question. So because we're on Canvas, and you guys are fine working using the score, because we're on Canvas, they would like to have us track how you guys interact with each other. And so, if once in a while you have a question you can ask on the discussion board, that'd be great also. Yeah, go ahead and email it as well. So if you have, if once in a while you guys can ask a question on the discussion board, that'd be great. Because that's how they track us. I'm going to be tracked as how you guys use things. I mean, this semester is not going to be as big a deal, but I mean, we'll see. I'm all for whatever students can use, whatever students want to use to make, whatever they're most comfortable with. Because I know the discussion board in Canvas is not that great. Okay. So, yeah, go ahead and use it, and then we'll see what happens. If my administrators complain, well, that's okay. Well, I'll deal with it. Okay, I want to make sure you guys use whatever works for you. Okay. Other questions? And by the way, don't hesitate to just blurt something out if you want to blurt something out. Other questions about the video? Okay, so normally in a class like this, we do like 10 labs. In this course, we're going to be doing, there's really like 8 labs, but there's like 9 assignments that you'll have. Okay. It's going to be different. You only have 4 written lab reports this semester. That's it. But they're pretty in depth though, because you will be doing the air analysis, the air propagation, all that good stuff. So I say 3 of them are pretty in depth. 1 of them is not, if I remember correctly. The Ohm's law one is so-so, and then there's a lab on RC transients, which is so-so. But there's a lab on circuits. You're going to be doing a lot of analysis, and there's the last lab you're doing a lot of analysis. Now the other items, there's 5 video reports. You'll be doing. And the reason why I'm having you use video reports, well, number 1, the first lab to me is a kind of a pain because it's conceptual, and that means for me I have to read a lot of stuff from you guys, a lot of just explanations. The first lab is just you observe and you explain. And you can probably do a lot of the lab at home without the lab kits. Okay. Like in the lab kit, for example, and it won't be this big, but you're going to need a PVC pipe, and you're going to need some fur. It's fake. It's not real fur. It's fake. Okay. And you're going to be doing some experiments on charging things. But there's some things you can be making in the experiment. You're going to make a device called an electrophorus. So this is an example. It's homemade. Look at how simple it is. And you can get fancy with it if you want. Yeah, I want your lab reports to be with the equations typed, just like you did in Physics 205. Yeah, it's easier to read. Okay, so you'll be using the math type and stuff. Okay, just like last semester. Okay, maybe the number of points on each lab will be different. I mean, different from what you're accustomed to from last semester. But from instructor to instructor, we're pretty much the same. We pretty much have the same demands. We pretty much expect the same things. Maybe one of us might look at different things than somebody else and be great, but we pretty much ask for the same things. Okay. You can start, this is not in your lab kit. So for your lab, your first lab is called properties of charge. And I got to talk about properties of charge. But for the first lab, okay, and you have to, there's actually 2 videos for this lab because you have to build equipment. So you can get started on it right away, right after this class. The first thing you're going to do is build this guy. This guy's called an electro. Mine's very sloppy, okay? The idea is to show how simple it is, okay? This is a device called electrophorus. This is to demonstrate charging, and we'll talk about this. So you got to build this. So what do you need to do to build this? Paper plate, okay, aluminum foil, and I use a cup, and I use PVC glue to glue it on. Okay, so this is all it is. If you can get as fancy as you want. If you want to actually get an aluminum plate and put an insulating handle on it, go for it. It probably work better if you do it that way. Okay. And so we're going to do charging by induction for this. And so you need to build this. So, and then there's another device called an electroscope. It's a device that measures charge. Basically what it is you have a conductor with 2 leaves. And what you're going to be using for the leaves are basically strips of aluminum foil. So you're going to attach strips of aluminum foil. This could come from a coat hanger or whatever. And this whole thing will be in a jar with a plastic lid. Okay, and so when you bring something that's charged here, these leaves go apart. Tell you have charge. So when you look at the lab properties of charge, I have links to how to build one of these. You don't have to use the link I gave you. If you go online, you can use whatever link, however you want to do it. Okay, so you can build this stuff now. In fact, this will be doing 2 weeks. Okay, So what I want you to do is build them and make a video of the equipment. And you can show that this is working because you can actually take a rod, charge it, bring it to the top, and these things will spread out. When you make the electroscope, make sure that the aluminum foil is very thin. The lighter, the better. Do not use don't use that heavy aluminum foil because it's too heavy. The leaves will come apart when you charge it. So what happens when you bring something charged here, the electrons will, if this is negatively charged, the electrons will go as far away from this charged object as possible. They'll come down here. You have electrons here. You have electrons here. Light repels, and so these guys are going to repel each other. That's the way to measure charge. So you're going to build those. So you can do this. You can start the lab without the lab kits. Okay. So Elia or Eli, I'm sorry if I mispronounce your name. Go ahead and get started. Okay. You have instruction on how to build these two items. And what I want you to do is videotape yourselves with the two items. I want to see your face in the video. I did this last semester and people wouldn't show their face, but I want to see your face in the video. Okay. Are we okay with that? And that should be pretty easy. To me, the reason why I do this is because it gives you like it allows you to do the assignment in steps. Okay, so once you have it, because you're going to use those tools in the experiment, it is a shortened version of the one that we normally do. Yeah, there's no for this lab there's no conclusion. What I want you to do for this lab is after you turn in this video and you want to do the lab, what you want to do for the second video is demonstrate something. You have to demonstrate every single thing that you did in the lab. Demonstrate most of the items and explain why it worked. I just want you to say why it worked in the video. Okay? And just observe and explain. You use the video to explain things. How detailed of an explanation? It has to be related to the concept we're talking about in class. We'll talk about polarization of charge. It's got to be enough so that somebody else can understand. Okay, somebody else in your class can understand what you're trying to explain. Right? Kind of like teaching. You see, and you get to think about what you have to say at what level. I mean, it's going to be easier for you to explain it to someone in the class because you're going to be talking at the same level as someone in your class. Okay. Now, realistically, unless you post it on YouTube, in addition to submitting the lab on Canvas, other people are not going to see it. I'm the only one who's going to see it. Okay. So, and we'll talk more about this lab as we progress, because you have several weeks to do this lab. I got to give you enough time because you got to get the rest of the equipment. But for sure, you can at least build it pretty clearly. Okay. So if you go under modules, for the first lab, you can download the file that has the lab. And I noticed some people already downloaded the files. Just read through it. You'll see it's pretty easy to build. It's really easy to build this. This takes like 5 minutes. The electroscope will take longer. Now, by the way, I should say when you build the electroscope, a lot of times the instructions say you want a jar with a plastic lid. You might not have a jar with a plastic lid, so you can actually get an insulator and use it as a cover. It doesn't have to be a screw-on lid, it just has to cover it. Okay? So you could get an insulator like a piece of plastic instead of a plastic lid and put it over the jar. So, I mean, just so you know, and it can actually be a plastic jar too. peanut butter jars. Or you can use the mason jars are the ones. Okay. So the question is about the PVC. So this is negatively charged because when I rub it with fur, because the fur likes to transfer its electrons to the PVC. If you go online and you type triboelectric series, you will see a list of materials, and next to them there'll be a number which indicates whether they like to pick up electrons or give off electrons. And this will be at the bottom, it'll be negative. So this one, this guy likes to pick up electrons, this guy likes to give them off. And so we always rub these things with fur. And you rub glass with silk. The glass will become positively charged. So how these get charged will depend on whether one object likes to pick up electrons and the other one likes to give them off. If you have two materials that are made of the same thing, nothing's going to happen. Okay, no matter how much you rub. It all depends on how much, what the affinity is for picking up charge and what the affinity is for giving off charge. It's only the electrons that are moving. Okay, so I hope that answers your question. Oh wait. The PVC, I didn't read the whole thing, sorry. The PVC is negatively charged and forces the protons. Yeah, the protons don't move. It's the electrons that move. So in this thing, what happens is, when I bring something negatively charged up here, the electrons in the metal run away from here. They go all the way down. So if I bring something, my picture's messy, sorry, negatively charged, the electrons go here. And these guys, now you're going to have an excess of electrons. And I'm not saying every single electron goes there. I'm just saying whatever electrons in the conductor can move, they will actually try to go as far away from this guy as possible. They go into the leaves. The leaves now are both negatively charged, and they repel. Yeah, it's electrons, not the protons don't move around. At least in the material. Now, it's different if you're talking about an electrolytic solution. It's different if you talk about chemistry, a chemical solution. If you touch it, it'll transfer the charge, but you don't have to touch it. You can just hold it over, hover it over. Okay, you can just hover it over the electroscope. It doesn't have to touch it. Okay, so before I start talking about the material, like I said, 4 written labs, 5 video reports. And that's all that you're going to be doing this semester. Okay. Make sure you turn your lab reports in on time. Please don't play, it's going to be hard to plagiarize, and it's going to be hard to turn in all the reports. Don't plagiarize your lab partner's reports for the written ones. Okay. Sometimes students say, well, I didn't know we can copy. You guys already know that your reports has to be your own work. Okay, so don't copy other people's work. Because otherwise, if I get 2 reports that look the same, I will grade one of them. And then the score you'll get is the average of the scores between the 2 people. I'm sorry, not the average. The average of let me rephrase that. Yeah, I'm going to grade one of them. The score is 18 out of 20. Then each person gets 9 points. Okay, if they're copies of each other. And you guys should know that you can't do that because you already had physics 205. I'm going to use a standard grading, and this is approximate. Sometimes I go a little bit below 94, and it just depends. Question: is there only 4 people in this lab section? There was 13 when I checked this morning. They're not all showing up. That's okay. If you want, I'm hoping that some of you guys, folks, write on the discussion board, just so it looks like I'm using the discussion board. And we can use Discord, but if you can do some things on the discussion board, that'd be great. Just so it looks like it's used and makes our administrators happy. Okay. All right. So let's be nice to each other when we use the discussion board. All right, so let me go through, and I want to show you. I want to talk about properties of charge, so we understand the lab. Just 1 second. Okay, you can all see the PowerPoint, right? Okay, good. It's really a pain to work with 2 screens. I can't find my mouse. Hold on a second. Okay, finally found my mouse. So what I want to do is talk about some properties of the charge so we can understand a little bit about how the lab works, okay? Let me check on my time. All right. And this is usually what I talk about in the lecture, some of this stuff, but it's okay. We'll skip this on Friday, I guess. So far in what you've learned in physics, you've learned 3 fundamental measurements. The fundamental measurements you've learned are mass, length, and time. And when we want to denote these as fundamental measurements, we put a bracket around these letters. If you look at chapter 1 of your book, you'll see this. All the quantities you talked about in Physics 205 were derived from some kind of combination of these measurements. Whether it was force, velocity, acceleration, there are some combination of these measurements. And of course, for each one of these, I can associate a unit with them, like kilograms or meters and seconds. But there's another one we know called charge. That's also a fundamental measurement, and it has to do with the inherent electrical properties of materials. And there's some similarities between charge and mass. Okay, so let me write down some of the properties. Charge is a scalar. Charge is a scalar just like mass is. Charge is conserved. Charge is conserved just like mass is. Charge is quantized. What does that mean? What does that mean, charge is quantized? And I'm going to say some of this again next time on Friday. Okay. What does that mean that charge is quantized? It means it comes in multiples of this value. Charge comes in multiples of this value. This is coulombs. Okay? So any charge you can think of is some multiple or some multiple of this number. Even if it's a big number, like 1 coulomb. You might say, 1 coulomb, that's not big. That's a lot of charge. That's a lot of electrons. 1 coulomb is huge. 10 coulombs is very huge. 10 coulombs is the amount of charge probably that you would find in a lightning bolt. Okay? That's a lot of electrons. So charges quantize, and you can add and subtract charges like you can add and subtract mass. And charges exert force on each other. You saw this in mass, right? When you talk about masses exert forces on each other. It's a gravitational force. But these can be positive, negative, or 0. And here's the difference between mass and charge. Mass can only be positive or 0. Charge can be positive, negative, or 0. And as a result, these forces can be attractive or repulsive. Forces between masses are always attractive. That's a big difference. Okay. So and I'm going to go over these again on Friday. These are the main properties. These are the properties of charge, and it's conserved just like mass is. Okay. So let me say something about materials. There's different types of things we can talk about in nature. We can talk about atoms. Oh, what's an atom? Well, these are what makes up the elements of the periodic table. So an atom has Z protons, that's the convention, and Z electrons. We're talking about a neutral atom. Z protons and Z electrons. I'll do this so it looks like a Z. Okay, it's neutral. It has the same number of protons as electrons. So if you have, let's say, a helium atom, it has 2 protons and 2 electrons. If you take off one of the electrons, then you have an extra positive charge. You have one more positive charge than negative charge. And so what we have then is an ion called helium plus. The electrons are on the outside of the atom, and so the electrons can be easily removed. The protons are in the nucleus, and they're attracted by the nuclear force to neutrons. They stick together. And so you can only, if you want to change the chemical properties of helium, you have to do something to the electrons. If you take out a proton from the helium atom, what you can do, it's not helium anymore. Helium is defined because it has 2 protons. When you take one of these out, then you have hydrogen. Oh, by the way, this has also 2 neutrons. The mass of the protons and the neutrons are about the same, and they're about 2,000 times as heavy as the electrons. So most of the mass is due to the protons and the neutrons. So we describe the mass of the helium atom in terms of its protons and neutrons. The sum of the masses of the protons and neutrons. Yeah, this comes into play, but you're out by fact. This is what factor of 2,000 small, and if you have to be really precise, then you factor them in. But to an excellent approximation, the total mass of this is basically the mass of these two plus the mass of these two. To an excellent approximation. Okay. And in fact, if you're somehow able to do some sort of nuclear reaction and take one of these out, you have a hydrogen atom with two neutrons in it, and it's called tritium. Okay. So you can remove the proton, but it's extremely difficult. You have to do a nuclear process. It's a really highly energetic collision. Electrons are much easier to get rid of in an atom. Okay. So if you take off an electron, you have an ion. If you add an electron, you have an ion. So it's interesting, FYI, it's interesting with atoms. You can form ions in atoms. You can form very highly positively charged ions of atoms. You can take uranium and you can strip off 91 electrons. Okay. You can actually do that in the lab. You can actually strip off 91 electrons. Of course, it's very highly reactive. So that question, can you get a negative mass with quantum mechanics? Yeah, that happened when Dirac solved his equation, but it really, what it represents is it's not really negatively charged. It's a particle with the opposite charge, a positron. And we're not going to get into that. I mean, the Dirac equation is an extremely complicated equation. We don't want to get into that. Okay. Anyway, so you can strip off a lot of electrons and get something highly positively charged. But, and most people don't know this, the most number of electrons you can add to an atom that we know of is 1. And it's only for certain atoms. I cannot add an electron to helium. They don't like it. It's happy the way it is. Okay? But I can add an electron to chlorine. Like it likes it. And you get chlorine minus. It's called a negative ion. You can add an electron to a sodium atom. It becomes a negative ion. There's some atoms you can't add the electron to it. Like nitrogen, zinc, you can't do it. Okay? But the most number of electrons you can add to an atom in a gas phase is 1. Okay. We know that by experiments. Of course, there's other materials, there's molecules of complex systems where you can add 2. Okay? But I'm talking about something in the gas phase, not in the chemical system. Okay. Now there's also molecules. Molecules can be charged or uncharged. Okay? And molecules are combos of atoms. Like H2O. Okay. And molecules can be ionized, or they can be neutral. If any one of these are ionized, they have they have distinctive electrical properties. They're charged, right? But even if they're neutral, they do have electrical properties. If something is in neutral, it does interact with an electric field. And I'm going to do an example. Then there's an interesting, you probably don't talk about in chemistry. You can set up molecules like this. They're called clusters. These are just clusters of molecules or clusters of atoms that they have a special name. And people have been studying them over the years. Okay, this is where the buckyballs and nanotechnology started from. It started from this thing. Okay. They're just clusters too, and they can be ionized too. You can put an extra electron on it. In fact, I think this one you can probably add 2 electrons on it. So that's what when we talk about atomic structure, we can talk about either atoms, molecules, etc. And these make up all the materials that we know, like the table, your book, etc. Now, these materials that are made up of atoms and molecules, they get their electrical properties because of the electrons. By the way, the chemical properties are because of the electrons. The chemical properties the material has is because of the electrons. The electrons play an important role. Thermal properties also are dependent on the electrons. What I'm going to do is, I'm going to define 2 materials. I'm going to define what's an insulator, and I'm going to define something called a conductor. I'm going to be using idealized definitions. And it's just going to help us to understand what's going on when we talk about properties of charge. Okay, my definitions are idealized. So, an electrical conductor, you have a small fraction of the electrons in the metal that are free to move. They're so loosely bound to the atom that the electrons are free to move. What's causing the electrons to be loosely bound? Well, because in the electrons, because you have a metal, the atoms of each of the metals, they interact with each other, making the electrons more loosely bound. So there's going to be a small fraction of the electrons in a metal, like a can, okay, that are loosely bound. So the electrons can move around. You have a sea of electrons, a small sea of electrons. You have no problem moving around the material. An insulator is different. A perfect insulator, the electrons can't move around. Okay. And the positive charge doesn't move at all. And I'm talking about solids, and I'm focusing on solids. I'm not focusing on electrolytic solutions, or I'm not talking about gases right now. Because if you have ionized gases, you can have positive charges that are moving. If you have an electrolytic solution, you can have positively charged atoms that are moving. I'm focusing on solids, okay? So, the electrons can't flow very easily. In fact, ideally, they don't flow, they don't move at all. Okay? But most insulators have a property called polarizability, in which you can take the charge in the molecules and separate the positive and negative charge within the molecule so that they actually have some electrical behavior. We call these materials dielectrics, by the way, these insulators. There are some molecules that are already polarized. They're called polar molecules. Water is an example. And they easily exhibit electrical behavior. I'll give you an example. I have an old helium balloon. The balloon's kind of old. Okay. It's losing its helium. And I'm going to take this PVC rod and charge it with the fake fur. And this thing is not charged. And it magically rises. And it magically sinks. I can do whatever I want with it. Oh, that's too far. I'll bring it up again. It attracts. Why is it that? But this thing is not even charged. That's lost charge. Hold on a second. You do lose charge after a while to the atmosphere. The more moist the air is, the faster you lose the charge. But you see, the balloon is not even charged. The effect is strong because of the fact that the balloon is filled with helium. What's going on? Well, here's what's going on. Let me draw a picture. Let's pretend this is a PVC rod. I made it negatively charged. Okay. Normally, an unpolarized material, the distribution of charge in the molecule is uniform for both. Their charge is evenly distributed in space for both. And I have to draw two circles because I can distinguish between them. Okay? You have a nice distribution of positive and negative charges everywhere within the molecule. But when you put this guy near it, what happens? Well, the electrons don't like each other. And so what happens is the positive charge is attracted to the negative charge. Now I'm going to read the story. The negative charge in the molecule runs away from this guy. So now you have a net positive charge close to the rod, and you know opposites attract, and so that's why the balloon was attracted to the rod. You've polarized the charge within the material. And it's temporary, right? What you've done is temporarily induce the charge because you temporarily induce the charge on the surface. You can also do it permanently. We'll talk about that later. Okay, you can also permanently induce the charge, but you temporarily induce the charge on the one surface of the material, and so that these two objects attract each other. Same thing happens when you take a balloon, you rub it on your head, and attach it to a wall. Yeah, the balloons are dielectric. It's an insulator. So you rub it on your head and stick to the wall. Because what you've done is this. You separated the charge on the wall. When you put it on the wall, you separate the charge on the wall. The positive charge on the wall is closest to the balloon, so they stick together. But this is always true. An uncharged object will always be attracted to a charged object. Are there any materials you can induce a charge in? I don't know any that I can think of. I mean, you could probably find a material where the effect is weak. I had an awesome demo I wanted to do today, but because they closed out the school because of the air quality, I couldn't do it. So maybe on Friday I can get the equipment. I get a 2x4, and I balance it on a petri dish, and I bring that rod next to the 2x4. And I can make the rod spin. And the rod's completely the 2x4 is completely uncharged. Yeah, I don't know of any materials where it's not going to happen. It works better with water because water is already polarized. And it works best with metals. So let me do this with metals. I have to adjust the camera. Hold on a second. I have to adjust the camera real quick. I have to get my hand. Very difficult to use demos when you're not in the lab. Hold on a second here. Okay, so you all see this can. The label causes problems, but it's a metal can. It's a nice metal can. It doesn't have any coating on it except for the label. This force will be strong. Because once it gets close, I'm in trouble. With metals, the effect is much stronger. Okay. It's not a webcam. That's attached to my computer. Okay, let me change the view here. Okay. Close that. Okay. One more thing, I gotta check if I'm still filming on my camera. Okay, everything's working. So, what happens? Well, when we bring a charged object next to an insulator and we separate the positive and negative charge, if we can measure the distance between them, we'll call it L. Okay. We form what's called a dipole. And I'll talk about more, I'll say some more about this next week. Okay. And the dipole is defined by the letter P, the vector. It's the charge, because both the charges are the same, times this L, and it's a vector that points from the negative to the positive charge. Okay. We form what are called dipoles, and P is the dipole moment. And this is called, and I should say it's an electric dipole because there's also something called a magnetic dipole. In a material that's polarized, a polar material, the dipoles are randomly oriented like you see in that figure. Those arrows represent dipoles. Okay, so this is polar, like water. Those arrows just represent the dipole moment. They don't represent the water molecule. When you bring a charged rod near it, what happens is that the dipoles orient themselves towards that charge. Okay, so I will say this is an exaggerated picture. What you do is get an overall orientation. Not every single one gets oriented, but this is just for illustrative purposes. Okay. So you get an overall orientation of the dipoles towards the charged object, and that's where you get the attraction from. That's why we talk about polarization, because you form a dipole moment. So let me check the time here. I got 18 minutes. So what is charging by contact? What do I mean? So when I take the fur and I rub it, what am I doing? Is it friction that's causing it? Well, what does the friction do? The friction allows the two materials to interact with each other. But what really is relevant to the effect of charging the materials is the fact that one material likes to pick up charges and the other material likes to give them off. You know stuff like that in chemistry, right? You compare like the elements in the first column of the periodic table and the elements in the seventh column of the periodic table. One likes to pick up the electrons, the other one likes to give them away. One's a proton donor. I'm sorry, one is the electron donor, one's the electron acceptor. Okay, so there's something called a triboelectric series. Now, I don't expect you to memorize this. Where people did experiments and to see, whether they material will want positive charges or negative charges. So the more negative you are in a series, it's just a number that's assigned in the series. PVC and rubber are at the bottom of the list because they're the most negative. Glass is positive, so it's like higher in the list. So glass likes to be positively charged. So if you take glass, and rub it with wool or silk. Silk is actually better. When you rub it, the glass will be positively charged. And it's weird. It's very weird that materials tend to be are good at getting negatively charged as opposed to positively charged. And in fact, what happens is when I rub these two together, this becomes negatively charged, this becomes positively charged. Why? Because it is transferring its electrons to this guy. It likes to give off the electrons to this guy. Friction allows the interaction to take place, that's all. It's a conduit for the electrons to take place. Okay. If you take two materials that have the same, like two pieces of saran wrap and you rub them together, you can rub them together until you glue them face. You're not going to get any charge transfer because they have the same electrical property. You have all kind of friction going on. Friction is just a conduit to allow the charge to transfer. What's responsible for that charge transfer, really, you need to have two materials where one likes to donate the electrons and the other one likes to pick up the electrons. Okay. And like I said, friction is really the conduit for that to happen. Because you can have situations where friction won't cause any charge transfer when you have two materials that are the same. Or they have the same value of triboelectric series. You can look this up online and you'll see a list of how, which materials like to become positively charged and which materials like to become negatively charged. So we can talk about the temporary induction of charge. When you bring a charged object next to an uncharged object. So let's say this is a conductor. And I bring a negative charge near the conductor. What's going to happen? Okay, the picture is exaggerated. Okay, the picture you see in the slide. But what happens is the electrons in the conductor don't like this guy. They move away, leaving the positive charge here. And that's what happened to the can that you saw roll. Okay, so what we've done is temporarily induce a charge on this surface and temporarily induce the opposite charge on this surface. It's a temporary induction charge, but we can make it permanent. We can make this a permanent one. So what I do is the following. I attach a wire to ground. Actually, I can touch it. If I have one hand touch the ground, and I touch it, the same thing will happen. But I touch this to ground while this guy is near it. What's ground? I got to say, what is ground? Okay, electric ground is a source or sink of electrons. Okay, it's a source or a sink of electrons. What that means is that it's the Earth, basically. The Earth has as much, it's like a drain. So what happens is, if I connect this to ground, guess what the electrons are going to do? They don't want to stay near this guy, so they actually go all the way to the ground. They stay as far away as possible into the ground. Okay, they want to go into the ground. They don't like this guy. Well, let's say I do that. And while this is there, I disconnect this. I mean, these guys, this excess charge is gone, and now my object is positively charged. Now you've done permanent charging by induction. That's called charging by induction. And that's what you're going to do with this. That's what you're going to do with this in the lab. You're going to have a piece of saran wrap on the table. You will rub it with fur, either saran wrap or transparency. Saran wrap works pretty well for this. I ran out of saran wrap, so I can do it. I can do it. But you take this fur and you rub the saran wrap rigorously on the table, for a minute. You take this guy, put it on top of the saran wrap, and you can while one hand is touching the water pipe, you touch the metal surface of this electrophorus, and then lift it up, and you bring your finger real close. You can hear it go tick. Okay. Or you can pick up little pieces of paper with you. Take little pieces of paper and cut them up, and you hover this over the piece of paper. You'll pick up some of that paper because you've charged this by induction. Another way to charge by induction is this. Let's say I have two spheres. Okay, and they're isolated. I'm going to bring a negative charge. I don't know why I use negative charge, but I bring a negative charge into this sphere. This sphere is supported by an insulating rod. What happens when I bring this here? Well, the electrons go here. I take another sphere and I bring it here. Put in contact. That's what the sphere. Okay. These electrons go here. While that's still there, I take this away. I get positive here, negative. I take this away. Now that's positively charged. So I reduce the charge on there. And the other was negatively charged. And I didn't have to touch ground. So that's another way to charge by induction. There's no rubbing of materials. Okay, except maybe for the first object. Okay, so that's charging by induction. So you can charge by contact or charge by induction. Those are the two ways. And so your lab is based on looking at these properties. And I didn't have time. I was supposed to set up a poll for this question. And so, let me check the time. Okay, I got a few minutes. I was going to set up a poll, but I didn't get enough time. But this is the question I like. I love to ask. It looks like an SAT exam question. So somebody has 5 styrofoam balls. They're suspended from insulating threads. And this person does several experiments and finds that ball A attracts ball B, but repels ball C. So A attracts B, but repels C. And then ball D attracts B, but has no effect on E. And a negatively charged rod attracts both A and E. So the question is, what can we say about the charge on each ball? We say A attracts B. And we call C. B attracts B. D has no effect on E. Okay, so based on that information, what can we say about the charges in all the objects? By the way, on Friday, then we'll start talking about the actual nature of this force called a Coulomb force. Okay, we'll talk about that on Friday. So what can we say? The fact that A repels C, what does that say? Okay, so I get one person saying D is neutral, A is positive, C is negative. Okay, so. Now be careful, because if you say A is positive and C is negative, okay, A is positive and C is positive. So let's write that down. Anybody else want to say anything? So you said D, what did you say? Yeah, A and C are positive. And then D is neutral. What else? What can you say about B and E? E is neutral. And B is negative. And really, to check your answer, are these choices consistent with what happened? Let's see. These two are oppositely charged, so they have to attract each other. That's correct. You're saying these two have the same charge, they attract each other, that's correct. This establishes that A is positively charged because a negatively charged rod is attracted to A and B. Because we already know A is charged from these two. Or we know A is charged from these two because of the repulsion. Because remember, a charged object always attracts an uncharged object. Okay? A charged object always attracts an uncharged object. If the two objects don't have an effect on each other, that means they have to be uncharged. Okay? So this is correct, that both D and E are uncharged, because they have no effect on each other. And so if D was charged, then this would not be true. If D was charged, this would not be true. Because we've established the fact that a charged object is always attracted to an uncharged object, and vice versa. That makes sense? Okay. So this is actually correct. This is internally consistent with what happened. And that's what people forget. An uncharged object always attracted to a charge. Let's go. And vice versa. I mean, I can switch this guy and this guy in one phrase. It's same is true. Newton's third law. Okay. So yeah, this is the correct answer. Okay. And it's consistent with what happened. Okay. So remaining 2 minutes. Do you have questions? You can blurt it out or type it in, either way. Makes sense? Good. Good to hear that. It makes sense. So when you look at the assignment, the lab, there's a video I would like for you to watch where the person does more demos. That'll help you with the lab. Okay. And again, the first thing I want you to do for the lab is build the electrophorus and build the electroscope. And then you can conduct all the experiments. And if you want to, if you have some of the material already for doing experiments, you can give a balloon. Go ahead and you can get started. Okay. That's fine. I mean, a lot of the materials that are in this first lab are stuff you can get from Home Depot or whatever. Okay. Or you might have already. You might have balloons already. You might need, for example, there's a carbon salt and sugar. I'm sure you have that. Okay. So you can get started. Yeah, those are good balloons to use then. Read the lab, and if you have questions, just don't hesitate to ask me. Okay, because this is a weird. The way we're teaching right now is kind of different, especially for a science class. It's harder for science classes online. Don't hesitate to ask me any questions. Okay, and we have to communicate with each other. I'll join Discord. Okay, but I'll join the Discord. Okay. All right, we'll do that. So, other questions or concerns, or if there's anything that's not clear, I'd like to know. Read the first lab. There's a lot of stuff. We're going to be doing graphing later, so don't worry about graphing. I don't know, the graphing software might be an issue for some. If you use graphical analysis, fine. If not, I have an alternative for you. And I have instructions on Canvas. I have a document in Canvas for graphing software. Okay. Okay, so I guess we're at the end. We're at the end of class. Then we end at 12:20. So I guess I'll end it here. I think I just messed something up here. Okay, so if you have no questions, you can use Discord if you have questions, etc. And I guess if somebody wants to play Warcraft. All right. Okay, so I'm going to end it here. You guys, we'll see you on Friday.